So this brings us to yet another formula. And again, I'm just going to tell you it. It's going to maybe sit a little bizarrely with you, which is makes sense. There's this cool connection with e raised to the x power and this polar form that we came up with. And this is known as Euler's formula. So e, remember, that is a number you discussed in a previous math class. If we raise it to I times theta, it is equivalent to cosine theta plus I times sine theta. So there's this connection there. Now, if we take this even further, and here is like a nice little quick proof of it written out, we know this is our rectangular form for a complex. If we replace, and for us, actually, this was A and this is B, same, it's okay if it's X and Y. I replace X with what we found earlier, R cosine theta. I replace that Y with what we found earlier, R sine theta. And then we have that I. We factor out that R, which we did earlier. But now we have this connection that this is equivalent to this. So I replace those two things. And this actually gives us something known as the polar form. You will see it on your reference sheet as Euler's formula. It's just more specifically because we're bringing in the R. And so that's why we kind of notate it as polar form. If I go to that reference sheet, you'll see it right here. Okay, so you don't have to memorize this. So once again, we're just going to go ahead and go between two different forms. So here, this is saying, we want to say all the angles between 0 and 2 pi, and we're going to round to the nearest hundredths. We did this work already for that trig form. So let's just fill this out. Z, we found that to be root 10 cosine 5.03 plus I sine 5.03. And this little section of these videos, it's going to seem kind of boring. You're just going to write it in polar form, also known as our Euler's formula. Well, we have our R, which is root 10. E, I is a value as well, right? E is a number, talked about it. It's that irrational number. I is root 1, negative 1, root negative 1. But we also now know our theta, which is 5.03. In our last video, we'll see why this is important to know how to write it in this form. And again, I changed this to, and I should do it here too, approximately, since I had a round. So we did this work and we got Z equals 2, right? That's from our previous example. So now if I'm going to write it in polar form, Euler's formula, Z equals, we know our R, which is really cool. It's just given to us, which is 2. E is an irrational number. I stays put. It's root negative 1. And we know our angle. Now, our angle is 2 theta, and we're allowed to include 2 theta because of how this is defined. So once again, pay attention to instructions. And you just leave it like that. This one we also did. I'm actually going to have to scroll up because I forget what the answer is. 1 plus I root 3. And I'm just filling that out. I do not need this rectangular form to figure out my polar form, my Euler's formula, because everything is given to me here in my trig form. So Z equals, my R is 2, E raised to the I times 2 pi over 3. And so this is really helpful to go from Euler's formula to trig, then to rectangular. So looking at my Euler's formula, I know my R is 3. Then I have cosine, my angle's pi over 2, plus I sine pi over 2. And now, just like from the previous video, now I can just evaluate. Okay, 3 cosine of pi over 2 is 0 plus sine of pi over 2 is 1. So you can write this as 0 plus 3i if you'd like. You could also just say 3i. And then our last video, or a couple last videos, we're going to actually take some roots of these complex numbers.